All right, so as you may have noticed, we tend to start things off with water, so we will start with water pollution. And it's a good place on pollution to start as well because everything has the tendency or the ability to end up in the water. So if it's air pollution, for example, there's a good chance it's going to sink down and end up in the water. If it's something that's left on the ground like garbage, solid waste, the other type of pollution we talk about, runoff from that is going to end up in the water supply one way or another. So everything tends to end up in the water, and therefore all pollutants do as well. Most water pollution is what we call non-point pollution. That means there's not you can't really pinpoint exactly where it's coming from, but the majority of it is runoff. So as the rain precipitates down, it runs over these different surfaces and ends up going into low-lying areas, which typically is your surface water, or soaking down in the ground, which of course will take it into the groundwater. Also, make sure you remember the groundwater and the surface water are actually the same body of water, if you can remember that, and therefore any kind of contaminants will cross back and forth between those. So the big thing then, as you might imagine, that will be the factor in what, or if any, type of water pollution you're going to get from surface runoff, the non-point pollution, is going to be what kind of surface is it running over. It's what we call the watershed. We talked about that with the water resources. It's where the water falls on the ground in a given area, and therefore when that happens, it's either going to soak down into the ground or run off into lakes and ponds and other surface water and rivers. Therefore, if it falls on the ground, for example, in a farm, or you of course have water that's not only just precipitation but also irrigation on a farm, so that's also going to carry it. Whatever's on the ground on the farm, which would be mainly fertilizers, pesticides, etc., they are going to be the types of things that are going to go in the water. If you've got construction going on, it's just exposing a lot of dirt. You're going to have dirt and sediment runoff coming from there. Cities, urban runoff tends to have a lot of petroleum products from cars and things. Also heavy metals from just industrial processes are not uncommon in that type of runoff. So you have these things that are happening that are based upon the type of runoff, and the amount of runoff that you get is based upon what's going on in that particular watershed in that area. Okay. So, as I mentioned, one of the things that you can have is fertilizer runoff from farms. That's actually the biggest source of water pollution is fertilizer runoff. Keep in mind that water resource usages, agriculture uses the most water, and therefore it's going to have the most potential for runoff and water pollution from there. And the number one effect that comes from that is something called cultural eutrophication. And we call it cultural because it's human-induced. Sometimes anthropogenic eutrophication is also used. But eutrophication, if you may remember, is actually a last stage process of a natural process after nutrients build up slowly over time. In the human-induced type, the problem is it's not a slow buildup. It's an immediate effect. And it comes from fertilizer, soluble chemical fertilizer that runs off, usually from agriculture, but also sometimes people's yards. That feeds the algae. Algae's a plant, so it can only eat the inorganic stuff like mainly phosphates and nitrates. And so that algae will then multiply and bloom, and it will make the water so it's no longer clear. It'll make it more turbid. And you have seen this if you've seen a lot of lakes in the summer, particularly here in Central Florida, where it looks kind of like pea soup. That's the algae that has bloomed in there, and the sunlight then cannot penetrate through that, and therefore the plants that are on the bottom, that are holding the soil in place, that are aerating the water with oxygen from the bottom, that provide food, shelter, all that kind of stuff, they're going to die. Okay, so that's going to be bad for all the reasons that I said those plants were good for the other organisms. But another thing, even worse thing that happens at that point, is that now you have dead plants, more dead material in the water. And dead material means bacterial decomposition. There's bacteria in the water that we're going to start to eat that those dead plants. That's what they do. And when they do that, they will then absorb oxygen out of the water because they, being respiring organisms, use oxygen to break down their food, just like we do. That's what the oxygen we use actually does, is it reacts with glucose in order for you to use it. So bacteria do the same thing. Most of them, some of them are not. Some of them are fermenters. but most of them do the respiration as well, so they're going to use up that oxygen in the water to do that, and that, of course, is going to drop those oxygen levels to the point where it'll suffocate these fish and clams and crustaceans and other things in the water that need the oxygen that's in the water. Oxygen is very much a limiting factor in a lot of aquatic ecosystems. And then from there, then that triggers a kind of a positive feedback mechanism, because they then will become the food for the bacteria, so they're going to eat the dead fish also, and those oxygen levels can drop even more. Any questions about the process? Any of that? All right, so phosphorus, as you know, as you might have heard, or I just mentioned, so you did hear, nitrogen and phosphates are the main elements that algae get to grow on. Phosphorus, usually in a natural ecosystem, is limiting. It keeps the algae under control because there's not that much available in the water. So most of it's down on the bottom because it doesn't dissolve that well. However, people have made soluble phosphates for agriculture, as a fertilizer, as well as for detergents in the past, and it's also a component in the wastewater from wastewater treatment plant. Those then are the key ingredient, the missing ingredient, so to speak, the limiting factor. So when you put that in, the algae then takes off because it gets what it was missing before, being the phosphate that's actually dissolved in the water instead of going down the bottom of the lake. All right, so another type of water pollution that is common is organic waste. So this is differentiated from the chemical, fertilizer, phosphates, nitrates, calcium, etc., inorganic stuff we just talked about that cause the algae to bloom. And this comes in the form oftentimes of untreated sewage, runoff from animal farms. It doesn't have to be feces, etc. It can be dirt, actually. It can add organic components to it, but it's organic molecules as opposed to chemical fertilizer. Now, algae won't grow on organic molecules on its own. So in this particular situation, we don't really see algae blooms because it's got flow as well. So the algae don't have a chance to grow off that. The organic waste is going to be decomposed. But what you do see is, just like you saw in eutrophication, because you now got the organic waste being directly put in the water, is that the bacteria, just like they did with the eutrophic lake, they are going to eat that organic waste and therefore drop the oxygen levels. So you can see here that that level of organic waste in the water is what we call the biological oxygen demand, BOD. And that's the amount of oxygen necessary to break down that organic waste. So as the bacteria is doing that, they are consuming and the oxygen is dropping, and then eventually they'll have eaten up, if there's only one source, they'll have eaten up that organic waste, and the oxygen levels can start to recover again. So the three factors that we see that change here are water clarity. It's clear beforehand, but with the organic waste in some of the water and the algae, or not the algae, excuse me, but the bacteria in this case bloom, but that will also cause some cloudiness to the water. But the dissolved, so the water clarity goes down. The dissolved oxygen, once again, like we just said, that goes down as well. The biological oxygen demand actually jumps up at first, and then it decreases as that organic waste gets decomposed. That's what we call, that's a measurement, direct measurement of the organic waste that's in the water. All right, any questions? Moving stream, organic waste input? Okay. All right. So a number of other ones, the ways that toxic substances, etc., can get into the water, where they can soak down. Like I said, everything can end up in the water, so sometimes it's from runoff, sometimes it's things that soak down in the ground. There's a number of examples there. Also, we have thermal pollution. That is not really a chemical change or anything, but it's just water being used in industry, usually for like a power generation plant like we have here. And this is the Indian River, by the way. And the water comes out warmer, which for some things is good, like the manatees here, but it also promotes algae growth, bacteria growth, drops the oxygen levels, so overall that thermal pollution, that thermal water pollution, of course, is a bad thing. So we've talked a little bit about acid mine drainage, how we get that from mining, and the sulfur gets broken down by the bacteria, the sulfur, when you dig up the minerals, particularly coal. And because it's acidic, that's not only does that change the water chemistry of the lakes it goes into, but it'll also tend to wash out heavy metal toxins more. Okay. Alrighty, so another source of pollution, nutrient pollution, phosphates and nitrates, much like the fertilizer runoff from farms, from agriculture and people's lawns, is the direct point source output of treated wastewater. So this is one of the few things we still put directly on the water, so that does make it a point source of water pollution. And it's just simply we don't have any place else to put all of this water that we use. So this comes from treatment of domestic sewage and everything. And the process has 3 stages. In the primary stage, it is just basically sitting and settling. It just sits in a tank. And at that point, the bacteria that is naturally in the feces, solid waste, or this is liquid waste, but the solid parts of that, they're going to decompose it, and it'll go down and settle down in what we call sludge at the bottom there, and then you'll still have dissolved nutrients in it and everything that can be go further through the process. Now, if you had a septic tank at home, this would drain into a drain field underneath your yard, and that would be the end of it. But if you're talking about wastewater treatment at a facility, a plant, that's usually going to mean that you're going to have secondary treatment. And the difference here with secondary treatment is it uses aerobic bacteria. That's why you have an aeration chamber, sometimes called an activated sludge tank. But you have an area where you have aerobic bacteria, because this bacteria is not aerobic. Aerobic bacteria in there, and they can process organic waste much faster. So they will completely break down all the organic parts of it, all the carbon-containing parts of the sewage that are left. And then basically what you're left over with that is mineral water. Okay, so all the organic parts, all the carbon stuff is out of that, but you still have your phosphates, nitrates, calcium, all that other kind of stuff that algae loves. And then the last process at that point, what they will do is they'll sterilize it using chlorine, ozone, or ultraviolet light, and that's just to make sure there's no leftover bacteria, particularly pathogenic bacteria, in the water. And then they'll discharge it, usually into a lake, a pond, a river, sometimes the ocean if they're near the coast. And in small amounts, no big deal, but it has caused a lot of problems. It's been the second major source of nutrient pollution for lakes through the United States after agriculture. Because, like I said, that water still is full of minerals, and the minerals, the phosphates and nitrates, etc., will cause algae to grow and cause eutrophication. Okay, so there is a tertiary stage of wastewater treatment that is becoming more and more common. It's kind of making its way through the sewage treatment systems here in the United States, and that uses chemical or biological means. Sometimes they'll use nitrogen-fixing bacteria, for example, and that gets rid of the nitrates and phosphates mainly. So when that's done, you should have actually pretty much pure water, almost drinkable, or in some cases drinkable waters. They do recycle it in some communities. Questions about wastewater treatment? Alrighty. So what are some of the things that we can do? One of the main thing for runoff pollution, since that's the main one, is to try to divert it before it gets into a natural body of water. That's why we see all these retention ponds and things around here, around on this property, near shopping centers and everything else. Anywhere you have paved surfaces, that water's got to go somewhere. And so the ideal thing is to have it filter through retention ponds, etc., artificial wetlands, those kind of things. All those things will allow the water to evaporate, soak down to the ground, and also the nutrients and even toxic metals and stuff they might pick up from automobiles will be absorbed by the plants, and that will reduce the volume and increase the purity of the runoff before it gets into a natural lake. So that's kind of the system you see there as it goes through. So when you see these different ponds, like on this property, at certain levels, some of them you'll see are after big rain, they'll be full, and then some of them will not be, and some will be partially. They have a system where they overflow into each other. That's what the pipes and the culverts and the overflow stacks and things like that are in those structures. So that's the main thing for that. The other ones, of course, are within agriculture, just reducing your runoff altogether and using organic fertilizer. That is one of the biggest things you can do to reduce the other ones, and then just keeping other stuff out of the water directly. Oh yeah, and trash, of course, is another type of water pollution that we don't really need to go into at this point. All right, so then we're into air pollution now. With air pollution, most of it comes from burning stuff. There are what we call non-metal oxides, or oxides of carbon, nitrogen, and sulfur, NOx, COx, and SOx, that are your primary pollutants formed when you burn stuff, organic stuff. Okay? And these different things can have different reactions, and we'll go on into more details about what those different things will do in the atmosphere. But the second major category of air pollutants that's produced both from burning stuff and just in general is particulates. So these are just fine-grained things. These are molecules up here that are produced, but these are fine-grained pieces of whatever dust, soot that comes from burning stuff, little pieces of carbon. Could be something like an indoor thing like asbestos that got in the air. Even pollen is considered a pollutant because of the health effects that it has. And those are all what we call particulates. They're made up of little particles of things. And the thing about your respiratory system is that it can be something like a particle of sand. Sand is a very innocuous substance. It doesn't really do anything to you. But if these fine grains get into your lungs, the response from your lungs can be such that it can actually trigger cancer. So these are, and if it doesn't do that, it just irritates your lungs and causes a lot of other types of respiratory problems from that. So those are some of your main categories of what we call primary air pollutants because they come right from the source of them. And then you have formation of secondary air pollutants. Okay? And so one of them is the formation of acid precipitation from the production of sulfur and nitrogen oxides. These are some of the oxides I told you comes from burning stuff. And they react with water in the clouds and form sulfuric and nitric acid. And these are, of course, they're acids. And so when they precipitate down, the effects that they have on land, they will tend to wash the minerals out of the soil because acids make minerals more soluble. And so it dissolves it more. And also, if you have certain toxic metals like lead, mercury, cadmium, or arsenic in the soil, then normally all those substances are not that soluble, and the plants will only absorb small amounts of it. But if the soil becomes acidified, then they dissolve. All toxic metals are really only toxic when they dissolve, or if you were to inhale the vapors from them. So dissolving them makes them much more toxic, and also gives them the potential to wash out into the water. So in general, both of these things, and also just the general acidity on the leaves of trees and stuff, tends to mostly affect coniferous trees, pine trees, and it weakens them basically so that they're more susceptible to drought and insects and cold and other kinds of things that they might normally survive. All right, in the water, so that water is going to go somewhere. It's precipitation, so it's going to tend to go towards the water. Change the pH of water has a number of different negative effects on the aquatic ecosystem. It makes it hard for bones and shells to form. Both shells like of an egg, if you have turtles or waterfowl ducks and stuff that are raising their eggs in the water, or the shells of things like clams and other kinds of things that are calcified. And that's one thing. Also, the toxic metals I mentioned before being more soluble, they're going to also go into the water. That'll affect organisms in there. In particular, aluminum, which is high amounts of, not usually considered a toxic metal, but it is toxic to fish in large quantities, and that's a common reason to get fish kills after acid precipitation events. A similar thing happens with photochemical, what we call, oh no, I'm sorry, I skipped ahead a little bit here. Any questions about acid precipitation, etc.? All right, another secondary pollutant formation, atmospheric air pollution formation, is what we call photochemical smog. And this comes from traffic, from cars. Okay? And cars produce nitrogen oxides because of the high temperature and pressure inside the cylinder. It makes the nitrogen and oxygen react with each other. Voila, nitrogen oxides. Those are part of that's what goes in acid precipitation. But another thing that happens with that is that it will react with the other Another type of pollutant that comes from cars is gasoline and diesel fumes, vapors. And so those two together, and you get sunlight that gives you the photo part of it, it'll cause a reaction between those two substances, and you form things like ozone and PANs, both of which are very strong respiratory irritants and eye irritants. Okay, so that's what we call photochemical smog. You see a lot like in Los Angeles or other areas that have a lot of traffic, and it causes a number of respiratory problems from those particular ones. Let me see. So any kind of respiratory irritant, like I said, it could be pollen or dust, can cause a number of respiratory problems. So we're talking now about some of the health effects of these different air pollution problems. Your lungs react by producing excess amounts of mucus that can clog up your lungs, make them not work as well. It can also tend to foster bacteria like pneumonia inside your lungs. And so not uncommon to see people it's a very common way to die, basically. And so when you have bad air pollution events, it's not uncommon to see an increase in the number of deaths because of respiratory problems from all that kind of thing. Inside radon, let's go ahead and go to the picture slide. So this is now, so we got those particulates, acid precipitation formation. Read through those. Photochemical smog. All right, so just mention also that irritation goes to your blood vessels as well, so it can cause coronary problems and circulatory problems also. Makes them swell up. A lot of times these health issues are associated with a natural phenomenon called a thermal inversion. Okay, and that is when you have warm air above. Normally it gets colder as you go up. So because of different things like sea breezes and mountain ranges and other kinds of things, sometimes you'll end up getting a warmer layer above the city, and that causes instead of the air flowing up and away, it will cause it to be stuck there at ground level. So we call it thermal inversion or temperature inversion. And like I said, in certain air pollution incidences, disasters, if you will, this has caused increase in the number of people dying from these different respiratory problems because the pollutants are trapped down at ground level. So that's thermal inversion. And then there's a lot of things, a lot of indoor air pollutants, a lot of stuff we work around. Some of them are natural, actually. The number one is radon, which is a gas that seeps up out of the bedrock, and it is radioactive, so that means that it will cause cancer. It's the second leading cause of lung cancer, first, of course, being smoking. You got all other kinds of things, organic, volatile organic compounds coming out of plastics and solvents and other kinds of things. Of course, secondhand smoke, that's going to be a source of indoor air pollution problem. So what can we do about the air pollution problems? In transportation, there have been a number of devices. The one that's most famous, if you will, with air pollution is a catalytic converter. And it'll take your nitrogen oxides and your gasoline vapors and your carbon monoxide and convert those into nitrogen gas, oxygen gas, and water vapor. Okay, and those things normally happen in the atmosphere, by the way, but it takes a little while. And in the meantime, people that are around that, the cars that are moving and idling and driving stuff, they've been inhaling these other things that are bad, and so this helps to keep that from being out where people can be exposed to it. With factories, the next big source of air pollution, as you might imagine, are factories, particularly coal fire factories. There's a number of things that you can do. You can clean up the coal beforehand, or you can filter it afterwards. And there's been a lot of advances in technology that have cleaned a lot of, particularly the sulfur oxides, out of the air by doing that. And then just using alternative energy and other kinds of things that don't burn stuff goes a long way. And for your household, use alternative products that don't give off these potentially hazardous substances, and also ventilate. Open up the windows and air the place out once in a while. Stink. Just kidding. All right, so solid waste. This is garbage. What do we do with garbage? The main things, and we still use landfills. That's the main thing we do with garbage. Most of garbage, by the way, is paper, and that's followed by yard waste and food waste. So that's kind of good news, actually, because those decompose the fastest. But landfills, the big issue with landfills is not only, of course, that they take up space, but the major environmental concern with landfills is that they may contaminate the groundwater. So rain soaking through a landfill, never know what's in there. People throwing away batteries and paint remover and all that other kind of stuff. That water can soak down through the landfill and get into the aquifer if that landfill does not have a liner. Now, of course, new landfills that are built, they do. They put a liner down, but there's still plenty of old ones around that don't have them. And so these are constantly monitored. They monitor the groundwater around them. And that's a number that they also vent off the methane or burn it off to keep them from being from catching fire. They add a landfill. They layer the garbage with soil to help it decompose faster. So that's the main thing we do with our garbage, is put in a landfill. But we can also burn it. This happens in some areas, and in particular, you can convert to electricity. So that's obviously a good thing about that. The bad thing is that you have to sort it so much. You have to be so careful with it, with what you burn, because if you burn plastics, you burn something that contains heavy metals, that will put, both of those will put toxic substances in the atmosphere. And even with extensive amounts of air filtration and stuff, these are still a major source of air pollution. So they're not the greatest thing environmentally. You might think better to burn your garbage to save space, but you're introducing a lot of air pollutants in the process. Even if you have a very good system of filtration and stuff, you're still going to produce air pollution. And it's not super practical because of the sorting and everything you have to do to make sure you burn the right stuff. So that's using incineration. And then, of course, we didn't go to, no, I didn't put hazmats on there. So anyway, the third thing, of course, is mentioned in your actual questions is recycling. Reduce, reuse, recycle. And so that will reduce the actual overall stuff you throw away. But the recycling part, of course, is good, but it's still you're disposing of it in a way. It's being hauled away from the house. It takes energy to recycle it in the first place. That's better than everything going to landfill and producing products from raw materials, but the ideal thing is to use less materials in the first place. That's reusing them when you can. It'll also reduce the amount of new stuff you have to buy. So there are certain substances called hazardous materials that you can't just throw in a landfill. Number of processes can be used, physically encasing them, all those kind of things to reduce them getting out in the environment, incineration. I'm not going to go through all those. So be mindful of the bio and phytoremediation. That is an important concept. Be using bacteria in bioremediation, or the enzymes for bacteria. They use this a good bit with oil spills. And also phytoremediation uses plants to absorb usually toxic substances out of soil, sometimes out of the water, and then they can be hauled away, and that causes less disruption of the spill of the site there. All right, and then finally a comparison of your 4 classes of toxic substances. Organic ones are ones that mainly are from petroleum products or byproducts, plastic byproducts. Plastics are made from petroleum as well. Liver damage, birth defects, etc. You can see all these here. I don't need to go through all of these. Your biological ones are ones that are actually living organisms that are causing a problem. These bacteria and stuff produce their own toxins, so that's technically what's poisoning you. But these are from living organisms. And then heavy metals. So you see the different effects there and everything of these 4 classes of toxins. Any questions? All right, that's it for Unit 6.